Good evening and welcome to another LIDNUG presentation. We have speaking with us tonight Gil Zilberfeld from TypeMock, and he's going to be doing unit testing and spring cleaning. As per usual, just before we kick off, a couple of announcements and that. First off, as usual, we'd like to thank our primary sponsors. Without Oxweb, we wouldn't have the website. Pluralsight offers us prizes for our members, and Telerik gives us a rather nice CMS to play with. Upcoming presentations. We have one more this month, which is part of the LIDNUG and Wintelect package that we've been doing for the past couple of months. And that's Take a Drive with HTML5 by Jeff Procyse. And then in October, we have another Wintelect event, .NET Performance Tuning by John Robbins. As per usual, we have all of those and more listed on our Eventbrite page. Here's our links. The main LinkedIn group is on the web on linkedin.com, group ID 43315, and our support site at lidnug.org. The bit.ly links are there for calendars, for those who wish to sync their calendars to Outlook. Our Eventbrite page is lidnugevents.eventbrite.com, and you can follow us on Twitter and Facebook at LIDNUG or info@lidnug.org for our email. None of this would be possible without our management team and our moderators team, and I hope you would all join me in saying welcome to our newest member, Bethany Vanander. She's just recently joined the team, and we're looking forward to having some great presentations which she'll get involved in. So without further ado, I will hand the microphone over to the man himself. Gil, are you ready to come in, my friend?
Yes, I am.
Take it away.
Thanks. Let me just share this. That's you. That's me. Okay, excellent. So, hi everyone. My name is Gil Zilberfeld. I'm the product manager at TypeMock. And today we're going to talk about unit testing spring cleaning. Now, I was talking to Brian Madsen, one of the managers of LIDNUG who lives in Australia. He said it's spring there, so it's okay to do such a thing like this. This is not going to be an introductory session about unit testing. It's going to be something of a medium, intermediate level. If you'd like more information about introduction level unit testing, you can go to the TypeMock site. Give the links at the end. But the reason I'm doing this presentation is because people who have been working with unit tests for a while, I mean about a year and a half, are seeing other types of problems that are asking different questions than those who are just starting out. People who are beginners ask, which tools do I use, what do I test first, things like that, how do I test this? But what I'm going to go through today is a different set of problems, and this is, I hope you learn from it as I've learned from preparing it. Just a few introductory things. That's me in the picture. As I said, my day job is the product manager at TypeMock, and at TypeMock we are, apart from just doing unit tests, we also do a lot of Agile practices and XP practices, so have some experience in that, and I speak about these things. Actually, if you have a chance to go to Agile Eastern Europe next month, I'm going to be there talking about Agile stuff. Obviously, my expertise is about automated tests and test-driven development, and some product management. More information about me, you can go to my site, and Twitter, and Gmail, and of course to typemock.com if you want to learn more about testing and unit tests. Okay, so how did we get here? Our story begins something like a year or a year and a half into an effort that the team has took to do unit testing. So how did we get here? We might have taken different paths, and what we might have chosen our beginning point and the decisions that we made on the way really pushed us to this point. So different people will take different paths. Like, for example, at the beginning, was this a greenfield project, or was legacy code there? And obviously, while coding this year and a half, we had more tests and more code. What did we do with this code? Team. We started off with a team that decided that they wanted to do testing, which is fine. But over this period, year and a half, we might have new people might have joined the group, or people have left. So it's not just the same team there. And practices, we might have changed how we code during this year. For example, unit testing after or unit testing first, like test-driven development. Or we might have decided, unfortunately, at the beginning not having a continuous integration server, continuous build server. And we might be doing this, or might have gone through to continuous deployment. So all these kind of things might have changed over time and might have an aspect of what we're doing today. So what I encourage you to think about is your journey, see where you are on this. And when you get to this point, think about this, because it will have some kind of an effect of what you're seeing right now. Okay, so what do we see right now? I'm going to cover 3 topics. This is the first one, the long build runtimes. And I'm going to talk about it as in terms and the point of view of symptoms. What do we actually see, and what can we measure? Because we might have different subjective feelings about stuff, but we have some information at our fingertips that we're not using. And if we identify these symptoms, we can actually treat them. And I'm also going to talk about the root cause. And root causes and what actually happening there and what we've missed along the way. And at the end of the presentation, I'm going to talk about the root cause treatment. So let's start with this one, long build runtimes. We started out writing a test, a single test. That was our first test. And then we added more and more and more. And many teams just see this happening, long runs on the client. When I'm talking about long runs, that means from 10, 15 minutes, which may bother a few people, but may not be so much bothering for people, for some, but for a few hours, which really is a problem. Why is it a problem? Let's talk about feedback. When I run the tests, and okay, let's say I finished my task and I completed it, and I'm starting to run the tests. And the build cycle includes the build and running the tests. And let's say it takes 15 minutes on my machine until I get an answer if everything's okay. 15 or 30 minutes. Now, if I were a robot, then I would switch on to another task and continue in this task until I got the results of the tests. But fortunately or not fortunately, we're not robots. So what we're doing is giving the next task less attention that we do until we get the feedback of the tests, so we know that everything's working correctly. Our level of confidence in terms of writing code really relies on our feedback from the tests. So that's why they're there. So we have these kind of periods between completing the task and getting the feedback. And as long as if these kind of periods get longer, our productivity really lowers down. That's a problem. If you think about it on the client, this happens on the client. On the server, that's even worse. So we have long-running, let's say 2-hour cycle. On this 2-hour cycle, after I checked in my code, I'm going to wait or find some fill-up tasks and stuff like that. I'm not going to be as productive as I was working on the task. How do we know this happens? Well, basically, like I said, these numbers are in front of us. They're in the test report, so they're really easy to find out, and if it's not going to be subjective. Another side effect of this will be that people don't check in code often, and that means that if I'm going to wait 30 minutes to get a result from my task, I'd feel more productive by batching those tasks together and then checking them into the server to get one cycle of tests running. Obviously, there's a problem with that because the bigger the batch, there's a better chance of bugs creeping in, and that means that we'll be going back and fixing the code. And if we had tests run immediately, we'll fix them, and the whole cycle would get shorter. How do you know that people don't check in the code often? Easy. Look at the logs of the source control system. You can see exactly what happens there. And these are kind of things you can actually draw on the wall and see what happens. So these are things that are there. Just need to look at them. So what are the direct causes for this kind of thing? I'm not talking about root causes yet, but direct causes. So for this, I would like to take you on a journey for something like 10 years ago. And I think this was my first experience with test-driven development. I was just reading Ken Beck's book, TDD by Example. And I was inspired, and I thought this is what I want to do. And of course, before bringing this to my team, I decided to experiment on myself. I was working on a component at the time that required some queuing. So it wasn't really a TDD because I knew exactly how I was going to design it, but bear with me, I wasn't aware of these kind of mistakes then. In any event, after mucking about and writing a few tests, I wrote a real test that actually tested the system and completed the code. And it was something that sent a message, received a message, was working okay, and it ran something like 2 seconds. Until it was around MSMQ, so MSMQ needs to restart, stuff like that. Okay, so I was so happy I'd written a test. I was nowhere near to looking at how long it took. But this test entered the test suite. And over the time, as we continue, we add more tests. Some of them are very quick. Some of them take a long time, like calling the database or the file system or doing something, an entire process there. And we jam them up in the same source code because how we work is that we're working on a feature. In this kind of feature, we will have a test assembly where we put everything together, all kinds of tests. So inherently, we're building tests together. So when we're actually going to test to run the test suite on our machine, they're going to run together. There's no clear separation when the tools we use, like shortcuts in the IDE that run tests, even in context, they will run all those together. So that's a problem. We can't really control what we're running unless we're really scrutinizing it. And obviously, this would be the fix, but getting ahead of myself. Lower bar in the beginning, it's exactly that. Looking at this test that took 2 seconds, obviously I was more happy about having a test than looking at how long it takes. And as long as a team we're accepting this kind of tests into our suite, we're going to impact our effectiveness in the future, which is now. So this is something that we can look at. If you're starting out right now, this is something that you might want to check out from time to time, because it really does have an effect in the future. Okay. Next slide. What are the root causes? The root causes, and basically these two are going to repeat themselves in the other stuff as well, so don't be surprised later. First of all is misunderstanding the value of testing. So we know tests help us, and they give us a safety net to write our code, and they'll tell us exactly if something wrong when a test breaks. However, we simply forget sometimes that we're not talking just about feedback, we're talking about quick feedback. The quicker we get the feedback about the test results, we can be a lot more productive, a lot more effective. Another thing is that unit testing in general, like other things in programming, these kind of things are skills. Testing is something that you begin, you improve it, you can teach others, and you can learn from others. So it's a honest-to-God skill. And what I'm talking about here is actually doing stuff with the tests, and which is also part of this skill. And nobody teaches that, and we usually learn this on the way. And the skills need improvement. And obviously, there's a good solution for that, and we'll go to this one by the end of the presentation. So how can we treat long build runtimes? I'm talking about build and testing together. Something that stuck to me. Okay, a couple of things that we can do. First thing is look at the test runs. The information is there. We can actually create a histogram of the test and see how many run quickly, how many run slowly. Information is there with every run, so just need to look at it. Once we look at it, we can start doing stuff with it. For example, smart remove. Something like 8 months ago, I was talking to someone who was doing testing for a long time, working in a startup. He had a build and test cycle on the server that took 6.5 hours. Yeah. So obviously this guy is a very smart guy. He knows about testing, and a lot of the tests there were integration tests and system tests, stuff like that. And he was looking at ways to shorten the cycle. And one thing he noticed is that some of the code didn't change over time. Over time meaning 6 months to a year. So they built this kind of framework, I think it was in Ruby. And the code that they used did not change. It was working well, there were no bugs, it was stable. Yet, as we all do, our suite of tests exercises all the code. So what he decided to do was to remove tests from the suite. Now, that for people who are into testing, this sounds a bit horrible. But if you think about it, when we decide to write a test, that means that we are investing some time and effort. We invested time now in order to get some kind of safety in the future. So that's a bit of like we're doing risk management in our mind. Removing a test is exactly like that. I mean, the opposite direction, but it's also a risk management decision. So I hope you don't get from what I said in the last 2 minutes, go forth and remove tests. No. Remember, I was talking about thinking first, so that's why I called it smart remove. Don't remove all the tests, but you can look at other information you have in your source code, in your test runs. that can lead you to optimize these kind of runs and save a lot of productivity minutes. Okay, but not many people are going to do smart removes. What we can do is grouping. Like I said, when we write tests, we usually jumble them up in a location which is based on the feature we're working. For example, if we're starting to work on a mailbox component, then we'll have a mailbox test class, which includes all the tests in this class, which is fine because the context of writing tests at the beginning is this. But after that, not so much, because what really matters there is the length of the test, because writing the test is done only once. Running the test over and over and over again, many times during the lifetime of the application. So if we do the profiling, we look at the test runs and we see which ones take longer, we can actually do some kind of separation. We can jumble up all the short ones in one assembly and the long ones in another assembly. Once we did that, we take control of what we can run, first in the IDE and then in the server itself. So we can actually do these kind of things and shorten the cycles, because once I have the control, I won't run everything together. First, I'm going to run the quick ones, get the feedback. If this going well, I'm going to run the long ones. Now, I read, I don't remember, I think it was a year ago, a couple of posts about test organization in the code and how to move them from place to place and which consideration to take. My experience, the only thing that makes sense when you move things together is the performance and speed. So it's not location, it's not features. If you're looking for these tests, believe me, when the test breaks, one click and you get to the test. Systems are smart enough to get you there. So if you want to get really productive, this is it. Okay. So once we did that, we can actually do a couple of things both on the locally and on the server itself. Obviously, organizing the tests into different assemblies can give us control on the client in terms of shortcuts or mouse clicks. On the server, we can do something a bit more, because let's say we take something like a 15-minute run on the client and an hour run on the server, which is not too, it's not something you see, you see that a lot. So you want to cut down on that. Now, if we didn't remove all the tests and we want to run all the tests, we can do something. Whatever we do in terms of organization, at the end of the hour, we'll have our answer if everything's working well. I can't really cut down on this time. However, I can split the cycles in the server so I can actually get the release, the feedback from the quick running suite earlier. So I'll know if everything's green in an hour, but if something's red in the quick feedback cycle, I can know about this in 10 minutes. Again, cutting these kind of times will shorten the cycles of development, because I won't wait an hour to fix that. I won't be in the middle of something else. I'm going to just go fix that and quickly and check this in. Locally, and on the server, something that I haven't mentioned because it's not test related, but build time. Sometimes you don't need to build everything from scratch. We have at TypeMock some code that doesn't change too much, and the regular test run takes binaries from another continuous integration cycle into the build. So we don't build everything from scratch, and we show them the time. So we have another cycle when we touch this code. So you can really play with these things today and get the result you can as quickly as possible. Okay, final thing about this point is something you might want to consider, which is better hardware. And you need to take a very good look at this, but I'm going to give you another example from my sordid past. Around that time, 10 years ago, I was project manager of my team of software developers and testers. And part of the development was an algorithm. It was something that took something like 5 to 10 minutes to complete, which was not acceptable. We wanted something to complete in less than a minute. And we thought about it, and we measured, we estimated how long it's going to take in developer days and tester days, and machine days, to optimize this algorithm to cut it down to a minute. But then we compared it to what it would cost, what kind of how can we jump ahead if we just put more memory on the system, which was very low memory. And this project was, we were giving away not just the software, it was a complete instrument, including a PC that ran the software. So we can actually were able to put a cost estimation of what it's going to do if we add more memory. And once we thought about it, it became very easy because we knew that the project was going to be out in 2 years. So obviously, the cost saving today of hardware is going to be even better in the long run, because memory is going to be cheaper in 2 years. Which leads me to today. Today we can have better server memories, SSD drives. If you know that your process needs very big improvements, a lot of man hours, and it's going to take a while, think about, compare the costs of putting more memory in the machine. It does help. SSDs really help. So think about it. It's not. I'm not saying don't forget about all the optimizations you can do, but there is something that you can speed things up. That's the end of part 1. Let's start part 2. When people start out doing unit tests, they're already aware that they're going to write tests that are going to break somewhere in the future. And that's the truth. The thing is that software always changes, requirements always change, and tests will break. We write, and tests will break for 2 reasons. The first reason is the good reason. That's why we write tests for. We write tests, so if we break something when we introduce a bug, we'll know about it and go fix it. The other thing, though, is that the problem, the bad one, and I'm changing the code because some kind of requirement changed, and then a test fails. And now I know that that test is no longer relevant, and I need to either remove the test or tests or rewrite them. And the first thing you'll see, or is actually you're going to hear, is complaints. people complain about spending time rewriting the tests, or once I heard, instead of the tests working for me, I'm working for them. Stuff like that. You can actually take a counter, a manual counter, and test how many complaints you hear. And it's true, because there is work involved. You'll find yourself fixing tests. And you can see that in the test. Again, if you're feeling subjective about these kind of things, you can go to the source control logs, and see what happens there. And there's a strange pattern going on in terms of source control, because people won't check their code often because they're going to be afraid that it's going to break something, so they're going to batch these things up again and then commit. And then things will break, and then they'll need to do this kind of weird thing. When they do we'll actually see that test code is getting checked in often, because it keeps changing all the time. Okay, so what are the direct causes for this? Well, before I jump in, and it does involve that, and nobody teaches this thing, I want to say that although this kind of thing is real, it's like the perception that when you're going to start doing tests, you're going to write twice as much code. And it might be that you're going to spend more time on code. But the thing is, coding does not slow you down. It's not the typing that slows you down. It's the thinking. The development itself is a lot of thinking and a lot of debugging later. And this is the source. This is the source of the frustration. When we're talking about fixing tests, that's the end result. Most of the time we're spending about what the hell happened here? I have 3 tests failing. I touched a bit of code. Tests I haven't seen in a year now are now failing, and now I need to spend time understanding what happened there. Is it because these tests are no longer relevant? If they are relevant, what are they testing? Why specifically these 3 fail? The other 7 don't. We're going into investigation mode, like CSI Microsoft blog post I once written, and most of the time until we get from a broken test to a working test is really spent on investigation. And most of the frustration comes from this part, although we will only remember the part when we change the code and fix the tests. So, like I'm learning in the last few months about Lean. Lean tells us to optimize the whole, not things in the middle, which we can do, and I'm going to show you a few examples about that. But keep that in mind. So what we can do in the beginning, what we can do right now, actually impacts the entire length of period between found a bug and fixed a bug, or broken test to working test. So back to direct causes. What are the direct causes? The things I'm going to show you is something that is rarely shown. It's something you usually learn on your way. There's a team that I visited recently, and they've been doing testing for 4 years now. And recently they reviewed their tests, and they couldn't believe what they saw. But these were the same guys were writing 4 years ago. And I'm going to show you a few examples of that in a minute. And these kind of things of how to write tests better so they can help us in the future and minimize the time we're spending on investigations is rarely talked about. And usually it's something that you learn on yourself, and this is why you collect tests over time that are really detracting us from actually having a less frustrating experience. The other thing is the team standards. Again, we're lowering the bar. We're willing to accept these kind of tests into our test suite, and then we suffer later. So even if we know this thing, we can we assume that other people just starting testing right now will need to learn on the way, and that's okay. We can get the test to just route into there because they have some kind of value. But as I said, it's sometimes coming back to haunt us. Root causes, going back again, misunderstanding the value of testing. When you hear people complaining about tests needing fix all the time, it's usually because they forgot what we were writing tests for. I can argue that having tests in the first place and needing to fix them as requirements change is something I always be willing to pay against the case when I wouldn't have tests. Because obviously not having tests will drag development even longer. But this is more of a subjective matter because I can't really prove that in numbers. Nobody did a project twice, one with tests and one without. But it comes from forgetting what tests are for, what kind of productivity gains tests can give us, rather than the whole investigation. And obviously, testing skills can improve. Like the examples I'm going to show you right now, it's part of it. So I'm going to show you a couple of examples in source code format. And you can see the list here. I'm going to show you this on the code. But that's the first step. First step is just sitting down and reviewing tests. And reviewing tests is very easy to do. If you're doing pair programming and you're writing tests, review the tests. That's easy. If you're working alone and you write tests, grab someone by the ear to review your tests. It's very easy to do. And there are things that you can do right now to your tests that will make it better in the future. Like these things, which I'm going to show you in a minute. In 2 slides, really. But remember that after we review the tests, one more step, refactor. You actually need to do the changes. Otherwise, the test will keep messing with you, and you'll need to fix them. Okay, so examples. Okay, so these examples are taken from an open source project called ERP Store. You see the address at the bottom. This is my favorite Picon project, and the guys who wrote it, the French guys who wrote it, really built a nice application. This is an MVC application, written I think from scratch, and again a very good thing and a very good effort, because they actually put effort into writing tests, which is very nice. But I take these kind of examples because without any proper training, I would write the same tests, and I probably probably did a few years back. So I'm going to start with I'm going to show you 2 bits of examples. Most of the examples will be on the code that you're actually seeing right now. And I'm going to talk about how we may improve, how would we write them differently. By the way, I'm not going to show you the code under tests. I'm just going to show you the tests themselves, because these kind of things, that the patterns that we're going to see, are going to spread on different tests regardless of what we're actually testing. So let's start with the first one, names. The first and most important thing about a test is that it checks the right thing and reports correctly. Obviously, otherwise the test is useless. But second thing is that it better have a good name. And what is a good name? We see here that the test name is anonymous index. Okay, so let's say you haven't seen this code before, but probably haven't. And someone sent you to fix told you the test is breaking, go fix it. So what do we know? We don't know what we're actually testing. We can see from the class name, we're probably thinking about testing an account controller, which is something that is nice to test in MVCs. Okay, I can throw you a clue. There is something called an anonymous checkout controller in the source code. That's the only clue I'm going to give you. So we see anonymous index in the list of broken tests. What do we do next? We don't understand what it does. So what we need to do is, first of all, look at the code. Now, thankfully for us, this kind of test is shorter and kind of revealing what it's doing. So again, without knowing what it actually does, I created a new name, which looked at for anonymous control. Default is the index is unauthorized. Basically, that's from reading the test code, not something else. Okay, so this would give me probably a bit more information about what's going on if I see it fail, because I know what am I testing. It specifies what kind of scenario, which is, I'm assuming, is the default initialization of the stuff, and what I'm expecting to see. This is going to be very helpful if all the tests have this kind of pattern, because I can compare what's working and what's not working all in one place. Names are the biggest clue we can help ourselves with to shorten the cycle from a breaking test to a working test. I can't emphasize this enough. How do you get to good name? You grab someone by the ear, set them near you, and they'll tell you if it's okay or not. If they tell you anonymous index is good, grab someone else. It's very, very important to have a good name. From a good name, by the way, I can decide if this is a requirement that needs changing, or the requirement still needs to work. So it gives me a context whether I'm fixing a bug or changing it for a new requirement. There's a lot more. There's a lot I can learn just from a name. So I'm going to tell you for the last time, names are extremely important. Okay. Same thing. Okay, so what is this wet thing? Everybody probably knows what dry is. Don't repeat yourself. Don't repeat yourself is a good advice given the multitude of times we actually copy and pasted code, and then we needed to change this code. So we went to one place and fixed it, forgetting the other 3 places that we needed to fix, and later reminded by the customer who found the bug that it actually needed to be fixed 4 times. Now, dry is a very good advice for production code. Test codes, while it looks like production code, serves another purpose completely. And the test code, tests as opposed to production code, are supposed to get us from a broken test to working tests as quickly as possible. Obviously, they need to notify if something's wrong, but once they did that, the test code itself should help us get there. Remember, when you wrote a test and it passed, that's probably the last time you see it until it breaks. So what we're writing is very important for the next time we will actually get there. So what am I going on about? Okay, so dry is good for production code. Is it good for test code? So as you can see on the screen, the guys who wrote this code actually thought about this, and they decided that production code and test code are the same in this kind of in the meaning of don't repeat yourself. So what they did is they created the base class for the tests, and in the initialize method they call the base initialize. Just to give you a bit of taste about what's going on in this initialize, we'll get to this in a minute. It's a very small letters, and it doesn't end in what you see. That's the initialize in the base class. But we'll get there in a minute. Okay, let's get back to the point where this kind of test breaks, and I need to understand what's going on. So even if if I had a better name, I had a better starting point, obviously. But now, regardless, I need to understand what's going on. And I have basically these 3 lines in the anonymous index method, in the anonymous index test, which from this I need to understand if what's going on is okay or not. And that's hard to do. The reason it's hard to do is because most of the setup is not done here. And that's not that's customary in all test framework, right? You have this kind of a setup method or a test initialize method, which you can put all the things there, which is a problem because when I have a broken test and I need to understand what's going on and I don't see the setup, I have a problem because I need to either jump through, like here, different classes and source codes to make a mental image of what's going on, what kind of a scenario we're talking about. Well, what I could have is within the single test, have everything verbose top to bottom, and which I could read, and gather from that what's going on. Now, for the people who saw what's going on with the initialize, and they say, I don't want to copy-paste that 4 times, you have a good point, you don't. But that's for another topic, we'll get there in a minute. But if I have 1 test or a couple of tests of breaking, it would be much helpful for me if all the code was in one place. So what is wet? What is the difference? Is the opposite of dry. If dry says don't repeat yourselves, I try to come up with a proper acronym for wet and came up with write expressive tests. The test should tell you exactly what they're doing, all the information about what they're testing, why they're testing it, in what kind of scenario, what the result is, and you need to get all the information from the tests, not skipping around. Now, this is very controversial, obviously, especially with the example I chose, which is, why the hell do we need all these kind of initializations? Which leads me to the next point where I'm going to get back to this. Logic. So obviously the guys did a good job. They put a lot of things in the initialization and put a create controller here, which I'm not going to show you, but you can guess what it does. This is where they're putting all the mock objects. This is where they're creating the controller. And this is where they found a very clever way to invoke an action on the controller without calling the method. So basically, it's a bit readable, but there's a problem here. And people who have written tests like I did, starting from scratch without a mocking framework, probably felt that. And that is, you started with a very small mock, which does nothing. And then you need to test more and more scenarios. So you put a lot of logic in the mock objects or the tests themselves. And this is what we see what's happening here. We add more and more logic and setup in the code, in the test code, in order to test our production code. Now, I've said it before and I'll say it again. The uglier your code is, the uglier your tests will be. I'm standing behind this. But, and the guys try to do something better. And the problem is that the more logic we put into tests, like methods like that, like wrapper methods, controller, factory methods, stuff like that, which is not just out of the box and not simple, there's a risk of us entering bugs there. And we don't like bugs in our tests, so otherwise we won't trust our tests. Having these kind of logic statements, procedural statements in the tests, basically are a risk, but they're also a smell. And this is where I go back to this kind of thing. Not just the creation logic here, but also this kind of setup for the tests. This is, by the way, the initialize method for the test we're seeing. So it's not completely taken from two different code bases. This is a smell. If we have a very big setup, a common setup for the tests, means first of all, we might have a problem in terms of design, like us having to have a factory method for a controller and setting all kinds of mocks, which are all these dependencies. There's probably a design problem there. And people who check out the code will see what it is. The anonymous controller constructor will take, I think, something like 10 arguments. But let's put that aside. That's a design problem. The thing is that, and I think that this is something that the dry principle does, or something that we have all inside of us. We have something that is common and some things which are not common. So something common to all tests and some things that are specific to different tests. And we tend to put all kinds of setups inside a common setup method, even though we don't need it for the tests. So that confuses us even more when we come to investigate what's happening with this kind of tests, because we don't know what's relevant. This goes back to WET, the verbosity and expressiveness of tests. A test needs to have only what they need, the simplest logic that's going to get us to the final point I want to show you, which is this readability. Now, obviously, the logic sample seems readable enough, but this is because they hit everything under all kinds of methods. Now, this test, this is a medium-sized test in the code base. Might not look too not readable. It's not too frightening. I've seen worse. But we can get much better in this. We can go back to what the real problem is. The problem is that we want to spend as little time fixing tests. And in order to do that, we need to give ourselves the most information we can. So when the test fails, we get there. So I'm going to talk about readability in a minute, what it can achieve, but I'm going to tell you a bit of a problem here inherent in the test. As you can see, hopefully, there are multiple asserts. We have one on 155, and one on 161, and one on 166. Tests with multiple asserts, again, I usually smell, they test a couple of things, which it's okay for integration tests, but they come with a problem that's inherent in most test frameworks, and that is, how does an assert signifies a failure? it throws an exception. So for example, if the, oh, missed the one was 148. Okay, let's look at the certain line 148. If this one throws, if it throws an exception, so if a result.viewName is not an empty string, what we're doing is basically we're going to throw an exception and the test will fail. But we won't know anything about what happened on 149 and 155 and 161 and 166 because the test would not get there. Okay, so what can we do? We can split this kind of tests into multiple tests. The test for each one will have a different assert. This will accomplish a few things. First of all, we'll have all the tests with their asserts running. So we know exactly which asserts passed and which failed, which gives us a lot of information, and when we come to investigate the problem. We'll have much more shorter tests. Each requires a smaller setup. Each will be a few lines shorter, and we'll actually get to name something which is better for the test. If you have tests like this with 5 asserts, usually what goes with them is a very vague name. Like we have a password form doesn't tell us what we're testing, because it's hard to say what we're testing because we're testing for 5 things. So these two go together. If you don't write multiple asserts, you can get to much better tests because they have better names, they'll be shorter, they'll be more readable. Now I can talk about these kinds of things more and for a few hours, but I'm going to leave this at that and going to item number 3 and the final one before we conclude this with a big bang. And this one's not technical. And you see team motivation dropping after the big. Usually you see a lot of enthusiasm over in the beginning. People are very happy and they're putting lots of effort into writing tests. And so there's kind of a slump later on. And first of all, how can you actually identify this? So again, coverage drops. Now, I'm not a fan of a coverage as a metric for telling ourselves how good quality is. There's a lot of problems with coverage as we tested today, but I am a fan of taking the coverage percent as a proxy of how the team is doing in terms of tests. And this is a good proxy. Coverage drops from 2 reasons. First of all, people stop writing tests. They add more code, they don't add tests, coverage drops. Coverage drops also because what we talked about in Power 2. And if people are feeling they're fighting with the tests too much, sometimes they'd rather drop the tests altogether than to fix them. Again, the result is the same. We get to a coverage drop. Again, if you're not testing coverage, this would be a good place to start with. And if you're a coverage junkie, like a lot of people, do this not just for that. This is a good proxy, a good metric to look at. Another thing we see is that people don't look at the test results. And sometimes the whole CI cycle, continuous integration cycle, build and testing, stays red for a lot of time. And this is again something that we can actually measure and see. And a lot of time means days. So a build can go on to be red for a while. And sometimes people won't notice, but what usually happens is that not all people drop their motivation at the same time. So at the same level. So it kind of polarizes the team. There are people who really care about having the build green, the test screen run all the time, and those who lost motivations don't care about this. And because of this polarization, we have fights of who broke the build and what should he do now. Because if people who care about these things will go and fix the build themselves, but if the people who don't care now are breaking the build, there's going to be some fights about this and when it's going to be fixed. You're like, you broke the build. Yeah, I know. Going to fix it later. No, but we need to have it run all the time. No, I'm working on something else right now. And it really does create a lot of tension there. And unfortunately, the bad people win in this case. What are the direct causes? First of all is team standards. Again, and this is going back to what I said. The same people who are doing this, who started the effort, may not be today on the team. So the team composition might have changed over time. People less experienced came in, and we might not have taught them how to write these kind of things. And again, we might have accepted this because, for better or worse, we don't like confrontations. And because of that, we're willing to accept stuff rather than argue about it. And unfortunately, again, like before, having a low bar and letting these things slip usually comes to a point of conflict with the one that we tried to avoid in the first place. Again, these kind of things, these direct causes, or the first line. Root causes, again, people who, if we don't put a lot of effort into instilling the fact of why we need testing, people will see it as a chore. That's why people don't adopt testing today. They see it as a chore. Only people who understand what the value is will go on to adopt it. And the testing skills I'm talking about here are not technical. Writing tests, looking at the build results, identifying there's a problem, identifying there's a criminal who broke it, and making him fix it because he understands how important it is. It's part of the skill as well. Our part, our human part, in terms of teaching and mentoring, is also part of the testing skill. We can't really keep it to ourselves. So what do you do? There are a couple of things that actually work as a treatment. And first of all is pair programming. Now, you might not be doing pair programming, but I really advise that you do. If you're doing, you probably know what the benefits are. You probably know what kind of problems and issues come with it. But we're not going to talk about pair programming today, except for the fact that it's good for team morale. Because first of all, it's a good opportunity to learn and teach. If people with more skill sit with people who are more beginners, they can actually talk about and show them on the code. When tests fail, people see that and understand what a test is. So doing things together helps. If you're working in a silo, for example, you're working alone, if you want to write tests, there's a lot of discipline involved. It's very easy to slip back to not writing tests. If you're working together, there's a lot of inherent commitment, and like you watch me, I watch you, which makes the chance that people actually write tests the fact that they will do that, the chance is going to be a lot larger. Start by, if you don't do it today, there's a good place to do it because you've probably done it before, like bug fixes. If you were stumped before and you wanted someone to go in and check over your code, that's pair programming. Let's call it another thing today. But that's it. Work on these kind of things. Write tests for it. Review tests. I call it the law of the nearest ear. If someone walks near you, grab his ear and make him review your review tests. And it doesn't matter if it's someone who knows more about testing than you or someone who's a little less testing than you. There's a good learning opportunity for both of you. And once people work together on the same code and understand the code and understand the test, they gain a lot more motivation to continue doing this. Second thing I advise for is test-driven development. There's a lot of benefits going into TDD, apart from the testing coverage and the quality and design. If you're doing pair programming, if you're doing, even if not, you're thinking about this, TDD makes development, shall I say, more fun. It becomes like a game, especially if you're doing like pair programming. It's like if you're doing test versus code. It becomes like a motivator for writing code rather than just writing tests. And the funny thing is that once you start doing this, other stuff goes away. If you're doing TDD and you work together and you get a better design, you probably won't see a lot of the problems we saw in the maintenance phase, for example. Like you get better names and you'll get readable tests and a lot less bugs in the tests because you'll be watching each other's back. So you'll have less conflicts and less test changes. And if we're talking about long build runtimes, these are things that you can pick up because you will teach each other how to organize the tests. And there's a funny thing that when you're working alone, it sometimes feel like it's not going to be as bothering for you waiting for a test run to complete. If you're doing it in pairs, it's going to bother you a lot more. If it's your computer, for example, you'll feel like you're wasting the other guy's time. So there's going to be some kind of a push to improve that. TDD really helps, and I really encourage people to pick this up and move forward. Okay, the final thing you can do about this is very important in addition to the other two, is to publicize the results. And the results I'm looking for are like the coverage stuff, or test stuff, metrics that we're testing, or how long the build was read. If the information is not hidden in some kind of reporting tool in the computer, but is on the wall, people take action. They notice that and they take action. Even they say that this kind of things it's transparent. I can see through that. It doesn't really bother me. Unconsciously, things on the wall, information on the wall, not only encourage conversation about the topics and therefore push people to do the right thing, also unconsciously does this. People will get the push. So if the metrics are bothering you, put them on the wall and discuss them, and also show the results, the improvement. I would show the trend of coverage, because this encourages both the discussion of what can we do better, and then people will commit to doing other things in order to solve these kind of problems. If you keep it on a computer screen, that means that only people who care will go there and check it. And this, by the way, it's not about testing at all. It's about other stuff as well. Okay. We're getting to the end here, so thanks for bearing with me. Final thing that I promised you is how to deal with the root causes. Two things I recommend. First of all, doing retrospectives. If you're doing agile stuff, you probably know what retrospectives are, and hopefully you're doing them. This is a chance to look back on what you did until now and decide what's working for you and what you can improve. Talk about your testing progress. Look at the different metrics. Discuss them. Try to see what we can do about them. And retrospectives are a good place to discuss and remind ourselves of the values behind why we started doing this in the first place. What was so important for us to invest in this kind of tests. And this leads to the second thing, the refresher course, which can include the values. It can include techniques. If you're doing test reviews or pair programming, that's very good because you're halfway there. But you can take a break and just list the things that you know or learned and teach others. And again, you can learn from that. You can increase your skills and teach others to do that as well. So before we go, here's Monday's agenda. So today's Friday, and you're going back to work on Monday, except Jewish people who are going to celebrate Rosh Hashanah. So, what are you doing on Monday? A couple of things you can start with. The build. Look at the statistics you already have. Start to track it and start to track trends and other things that start with D. Review tests. And look at the test, look at what you're doing, look what other people are doing, and do this in pairs or groups. Learn from each other. Finally, try TDD if you haven't yet. TDD in itself is like a skill inside unit testing. There's a lot to learn there and a lot of chance to improve. And just start doing it. It may not be for everyone. Probably isn't for everyone. Not many people continue to do this for a while, but there's really see a lot of benefit in there. But there's no reason why you can't really try it. So go ahead and try it. And that's me again. So this would be a good chance for questions. If you have any, put them in the Q&A stuff. Otherwise, if you would like to get in touch, my site, my Twitter, email, and typemock.com, which you can learn a lot of unit testing also. I want to thank you for inviting me and let me share my interest and passion with you. Thank you very much. Pete?
Bethany's actually here.
Yeah, Bethany.
Can everybody hear me? Just wanted to thank you, Gil, for your presentation and thank everyone for attending. We hope you've enjoyed today's presentation. And Peter, I don't know if we have any additional follow-up, but I'll pass it over to you.
Yep, another great presentation. Thank you very much, Gil. It's been entertaining and enlightening, just as we'd hoped. Sorry you didn't get the attendance that we hoped we would get. But hopefully we'll get a lot more views on YouTube once we get it uploaded. I trust you'll come back and do some more for us in the future.
If you ask me, I'll come back.
Fantastic. That's great to know. Thanks once again. For those who missed them at the beginning, here are our standard links, and the people who are members of Team LIDNUG without which we couldn't do any of this. Thank you very much for attending. Okay, you can stop recording now, that's it.